tightly can you stroke your hair? How wide can you open your eyes? How tightly can you close your eyes? How wide can you open your mouth? How tightly can you close your mouth? How far can you stretch your arms in front of you?
All right. Welcome back, everyone. Next up is Rose with Plugin to Python, extending your applications through the use of plugins.
All right. Good afternoon. My name is Rose Judge. I'm an open source engineer at VMware, and today we are going to plug into Python. All right, so a little roadmap for where we're headed today. If you're not familiar with plugins, I'll go over what they are and why Python is the perfect language to get started using them. We'll do a little cost-benefit analysis, and then I will give you a deep dive into Tern's transition into an extendable architecture. So a little bit about me. I'm an open source engineer at VMware, and part of my role there is to co-maintain an open source project called Tern. Tern is a container inspection tool written in Python 3. You don't need to know anything about containers to understand this talk, so do not worry. But part of what motivated me to give this talk was my work converting Tern from just one host application into an extendable architecture for our reporting. So for the context of this conversation, a plugin, you can think of it as a software add-on that can be integrated into an existing code base or extended. It might extend or enhance the default capability of that tool or code base or application. And a really famous plugin that you've probably all used and are familiar with is the Adobe Flash plugin. You don't need it anymore, but you used to need this plugin for embedded content in your web pages. And just as the definition states, this enhanced the functionality of your core application, which was your web browser. Plugins might be added when there's a need for customization, and we see this a lot with open source projects. There will be a tool that companies write plugins for to customize it for their specific use case, whether it be hardware or just they need it to work for one of their internal tools. You might also see plugins when you're adding on functionality to a host application. If you've ever worked with WordPress, you know that there's like 50,000 plugins available to add functionality to your WordPress site. And then I thought it was also relevant to note that plugins don't operate by themselves. They rely in some way on a core set of services from a host application, whereas the reverse is not true. You can easily have a host application that does not have any plugins. And throughout this talk, I might use the word extension instead of plugins, but tomato, tomato. For today, they mean the same thing. Okay, so I'm a visual learner. Sometimes I think it can be easier to conceptualize things with a visual aid, so I found this lovely diagram on Wikipedia, and I think it does a good job explaining what's going on without overcomplicating it. So as I mentioned, there will be a host application. Inside this host application, there will be a set of services available for the plugin to take advantage of so that it doesn't have to reinvent the wheel. There will also be a services interface that will be a protocol for how the plugin can take advantage of these services. Inside the host application, there will also be a plugin manager, and this manager is responsible for finding and loading plugins at the correct time. And it can do that because of the help of the plugin interface, which helps give data from the plugin to the host application. And then the plugin itself is the set of code which customizes or adds on features relative to the host. So if I haven't totally convinced you yet that plugins are worth your time, I still have 20 minutes, but I thought I would give you a few examples of where you might have seen plugins out in the wild, with or without knowing it. So if you think of your favorite media player, most of them can support different types of file formats. So you might have an MP3 or an MP4 or a .wav, and The host application does the same thing. It plays these files, but the way in which the files will be processed and transferred to the actual player are handled with plugins. So depending on the type of format that you're inputting, there will be a different plugin to handle the processing of each of those. Think of your favorite IDE and how it can support a slew of programming languages. These are likely all handled with plugins. As I mentioned, WordPress, you can add on lots of functionality to the default host application of your site. And then Pretty Good Privacy is an example of a plugin for your email where your email client is the host application. Its default services are to send and receive mail, and then PGP can help you encrypt and decrypt and add functionality to that default service. And then last one, Photoshop has plugins where you can add tools and filters to the default set that's available to you. So plugins can be implemented in a variety of languages. Some of you may have done it in other languages, but if you're just getting started, Python is a great place to start. So first, there's support for abstract classes, and at the implementation level, this is the easiest way to get started. So if we think of that media player example, having some sort of abstract class and function to process, each plugin will have its unique way of implementing that process and before it passes off to the player. There's also this neat mechanism in Python called entry points, which are supposed to make it easy to find and load plugins. Setup tools in particular provides an entry points argument to the setup function in setup.py, and you can use this to register your plugins. Once your plugins are registered, you can use the package resources module to actually load and run those entry points. Part of the appeal of using entry points as well is that they can be distributed independently of an application. So the namespace setup tools uses to find plugins is different from the Python source code namespace. And because of this, plugin packages can be easily distributed separate from their host application. So it makes loading what you need when you need it easier. And last, but definitely not least, probably most convincing is that Python code is dynamically loaded at runtime, which means that you get what you need when you need it if you use plugins without having to add bloat to your application. So besides just using the native Python libraries, there are some open source tools and frameworks that can help you. I have not experimented with all of these. I'm most familiar with Stevedore, but if you get excited from this talk, this is a reference slide for you in the future. Okay, so when we decided to add an extensible framework to Turn, we decided to use Stevedore to help us through this process. So Stevedore is a standalone library from OpenStack, and it wraps the package resources module with a series of manager classes and provides kind of a nicer API to work with. Stevedore loads entry points using a namespace argument provided to it, and then works with the plugins depending on the nature of the manager. So the plugin manager, as I mentioned before, is in charge of finding and loading the plugins. And Stevedore supports 3 ways of doing this. They call it drivers, hooks, and extensions. For the purpose of what we needed, we chose to use drivers, and that's what this image is on the bottom, which basically means there's one name and then one entry point. So if we go back to the media player example, they would probably use drivers as well because there's only one plugin that's going to be required for one type of input. We also liked that the project was actively maintained and it had lots of good documentation and good examples, which is always important when you're working with open source projects. Okay, so like any decision in life, there's going to be pros and cons. So when you're discussing with yourself or your coworker if plugins make sense for your application, here are some things that you might consider. So the first drawback is that it just is going to take a little bit more time. All good things take time, so I don't know if this is necessarily a drawback, but I couldn't find a lot of reasons to not use plugins, so it's going on this slide. But when you're designing a plugin architecture, especially if you're like doing what we did, where you're going from a core application and then trying to set it up in an extendable way, it's just going to take some trial and error to actually do it. If you're starting from scratch, it's going to take a little bit more time to plan, but it's going to be easier to maintain and actually write that code in the future. And then kind of building on that point, plugins might not always be practical, especially if you're working with like a large legacy application that wasn't designed with plugins in mind. It might not actually make sense for you to go through the work of doing that translation. And then there are security considerations. And especially when you're using plugins or adding them to an application that you're using, it's important to make sure that they're coming from a trusted source, they're not malicious, they're updated and well-maintained. But also when you're designing an application to support plugins as input, it's important to think about this so that you're not setting up your users to be exploited by malicious plugins in the future. So despite those drawbacks, there are, of course, benefits, or I would not be standing up here today. The first is that plugins give you an opportunity to better organize your code. Instead of packaging everything together, you can separate the core and extendable parts of your code, which make it just inherently easier to navigate. Plugins provide versatility for your application. They make your application easier to customize and then provide the necessary flexibility to kind of add and remove features as needed. Number 3, maintainability, and this kind of builds on the organization piece, but not only is your code better maintained, but because there's a cleaner distinction between the core and the extendable parts of your code, it's kind of easier to anticipate, prevent, and resolve conflicts when large changes are merged into your project. And then number 4, it's easier for others to use and enhance your code, and this is definitely a benefit when you're working with open source projects. Giving users the ability to write their own code and add functionality to your project means that they might think of things that you've never even considered for your application. Also, lots of times in open source, you'll get requests like, hey, we love your project, but we need this customization. And if you have a plugin architecture set up, it's really easy for you to say, like, we love that idea, we don't have the time, but we made it really easy for you to do this yourself. So if your goal is to get more people to use your open source project, plugins are a good way to encourage them to do that. And then the last one is it just reduces the footprint of your application, being able to package your core application and plugins separately just kind of reduces some of the dependency bloat and makes things easier to manage and deploy. So those are the pros and cons in general. Of course, they likely will not all apply to your unique situation, which is why it's important for you to do the cost-benefit analysis yourself. But I thought I'd go over why Turn decided to make the switch to plugins. And the first is that we just wanted our code to be better organized. And I'll show you in just a couple slides how plugins helped us do that. And then the second is we wanted to make it easier for open source users to write their own plugins for Turn. So Turn is a container inspection tool, and basically it will go through your container and it gives you a summary of what it finds there. And it supports different ways to format this information, but we've had people come to us before and say, hey, we love Turn, we want to use it, but we can't because we need this special output style. And because there's only 2 of us, it doesn't always make sense for us to do that work to customize it for them, but setting up plugins made it really easy to say, look, we made it really easy for you to do that yourself. And then lastly, plugins helped us eliminate some redundant code where maybe we weren't always being efficient in the way we were parsing or error checking things. So before I dive into what Turn looked like before this transition, Turn will give you the software bill of materials, and like I said, we support 4 ways natively to do this. There's the default format, we have JSON, YAML, and then SPDX tag value, and you don't need to know what SPDX is, you just need to know that it is a type of format for this example. Okay, so before we implemented an extendable architecture, we didn't have any consistent location for the different output style functions. So that image on the left, you can see how Turn was organized. Naturally, all of the reporting code was under this directory called report, but within that report directory, the functions for formatting the actual reports were kind of all over the place. So JSON and YAML were in content.py. The default was in report, and then SPDX tag value had its own directory where its code was. And you can also see that the naming wasn't necessarily consistent in terms of what we called it. So we had like print JSON report, print YAML report, print report, and then SPDX had a generate function that did essentially the same thing. And this worked in the sense that the user got what they were asking for. So if they said, hey, I want a JSON-style report, Turn gave them a JSON-style report. But you can imagine how difficult this would be to scale. If one day we decided that we want to support 15 reporting styles, things would get pretty messy pretty quick. Another issue that we were trying to address by implementing plugins was to organize Turn's cluttered command line. And I apologize for the quality of this screenshot. The words aren't necessarily important, just focus on the colors. So as you can see, we had 3 different command line options for the 3 different reporting styles alternative to the default. And again, you can see how this would be really difficult to scale. If we wanted to support 15 different reporting styles, the command line would be a total mess. So after we used Stevedore to help us implement extensions, we were able to go down to just one command line argument, and it was called report format, and then the user could specify the type that they wanted. And Stevedore handled all of the parsing of what the user did, and then handled the execution according to what the user specified. So I thought the best way to show you the after was to kind of take it step by step of how I went through doing this. And again, SPDX tag value, you don't need to know what it is, but this is the example that I'm going to show is the SPDX tag value example, but we did similar things or almost the identical process for JSON, YAML, and the default style. So. Because Stevedore uses setup tools entry points to find and load the plugins, the first thing we had to do was tell Stevedore where to find the plugins. And there's kind of 4 parts to this mapping. The turn.formats is the namespace, which tells Stevedore where the plugins will be. The SPDX tag value, all lowercase, is the name of the plugin. That will correspond to what the user types with the command line option to format the report. The location of the plugin file is under Turn formats SPDX tag value in this file called generator.py. And then this camel case SPDX tag value is the subclass where we'll actually customize the plugin functionality. And now that we told Stevedore where to find the plugins, we needed to define an abstract base class to kind of set the expectations for all of the other plugins that we were going to implement. So we used the abstract base class module in Python, this meta class, and then the abstract method decorator. And basically what this does is tells all the plugins you need to extend this generate class, and then you'll uniquely implement this generate function according to whatever plugin you are. The third step was setting up the Stevedore driver manager. And as you might recall, the driver manager is responsible for loading and executing the plugins. So in this case, the name of the plugin is format string, and the variable called format string, if you look at the blue line above, format string comes from the function that calls generate format. And you can't see it on this slide, but basically that comes directly from the command line. So whatever the user types is going, Stevedore is going to look for as the name of the plugin. We could hard code the namespace because we organized all of them under turn/formats. And what this will do, what Stevedore will do, is it will take the name of the plugin, it will try to find it in the registered list of entry points, and if it can find it, it will call the abstract method generate for that plugin, according to whatever you told it to, wherever you told Stevedore to look in setup.cfg. If it doesn't find that, then it will throw this no matches error, and then we can deal with it from there. But it's really nice because Stevedore handles all the parsing and makes it really easy for us to error check the user input. The next thing that we were able to do by using Stevedore was eliminate this check format type parsing function. And so like I mentioned, Stevedore will handle all of the parsing. It will handle the matching. If it can't find it, it will handle the error checking. So we can just totally get rid of this check format type function. And then the last step of this process was to actually implement the unique SPDX plugin. And for us, this was actually the easiest part because we were moving from something that already existed to just a better organized way of doing it. But if you are writing plugins from scratch, this is where the meat of your code is going to will go. So this generate function is basically the SPDX tag values plugin unique way of customizing the output. You'll notice that the class, the camel case SPDX tag value, corresponds to where we told Stevedore to look in setup.cfg. And then that generate function was already written for us. We just had to move code from the previous organization into this extendable architecture. So I have shown you an example of how plugins benefited Turn, but the answer to the question, are plugins right for your application, will obviously depend on your specific use case. If you leave this talk considering implementing plugins in your application, these are a few questions you can use to get started in determining if it makes sense. So does your application have different sections of code that do the same thing in different ways? So the media player's example, it's doing the same thing. It's processing a file, but it's doing it in different ways according to the input. In Turn's case, we were doing the same thing. We were formatting a report, but we were doing it in different ways depending on the user-specified option. Number two, and this more applies to open source projects, but does your application have potential or want to allow customizations or additional features? So if the goal of your project is to get more people to use it, then I would say the answer to this is yes, because it makes it easier to push back on users who say, hey, I can only use this if it's done this exact way. And if you have plugins available for them to do that and customize it for their needs, then it's easier for users to engage with your application. And then just in general, do the benefits outweigh the costs? So going back to those pros and cons, there are obviously hundreds of stakeholders and questions you may need to consider in addition to these three, but this is kind of a good place to get started. If the answer to these questions for you is no, then probably plugins don't make sense for your application, and that's okay too. But either way, I hope you learned something today, and I'd be happy to discuss this further outside in the hallway. So thank you again for your time. RoseJudge5 on Twitter.
Thank you, Rose. All right, at 3:40, we will have Fen Slattery doing digital accessibility beyond legal compliance. 12 minutes from now.
record of the delightful piece they're going to play this evening.
Ladies and gentlemen, 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 your attention, please, attention, please, attention, please.
And now the moment we've been waiting for is here.
I have something to tell you. Can it be true? It must be true, no doubt, no doubt.
Life is going on as normally as ever.
But suddenly something seems to have happened. Suddenly something seems to have happened. Everybody seems to be staring in one direction. People seem to be frightened, even terrified. I want everybody to understand this.
I don't understand.
I don't understand.
There are a lot of things we don't understand. I don't understand.
We need answers from you. What did you expect to find? What did you expect to
Who's going to be our future?
It's your responsibility to do something about it.
Well, I have the key in my hand. All I have to find is the lock. The lock. The lock. The lock.
Now listen to me, all of you.
Yes. Test. Ho- Test. I got it. This one, I love wires. Wires always work. Awesome. Well, welcome back. Next up, we have Fen Slattery doing digital accessibility beyond legal compliance.
Thank you. Hello, everybody. Okay, cool. So, yes, as you've just heard, this is digital accessibility beyond legal compliance. And as you'll find out shortly, I am a big accessibility nerd. So these slides are up and available for you to read in an accessible format right now at bit.ly/2 lowercase t, capital C, capital H, lowercase w, lower y, lower m. And download my slides, and you can leave. Bye. See you. That's the end of this talk. No. Okay. But if you want to hear me talk about them, I guess we can do that too. As mentioned, my name is Fen Slattery. My pronouns are they, them. I'm the accessibility lead at Click Studios out of our Chicago location. And as you'll find out in a little bit, essentially what that means is it's my job to make sure that everything that goes out the door of our firm is accessible, which involves supporting developers, giving external talks like this, and I just say the word accessibility like 50 times a day at least. So. I am also a co-organizer of the Chicago Digital Accessibility and Inclusive Design Meetup, which is actually one of the largest accessibility or digital accessibility user groups in the world. So that's cool. That's fun. I want to know a little bit more about who is here. So we're going to go around the room. You're going to say your name, your job. No, I guess we can do the hand-raising thing. Or maybe, since the lights are kind of bright for me to see up here, we're going to do this in a more fun way, which is you're going to, make noise and raise your hand. Cool. So can you raise your hand for me, give a shout if you know anything at all about accessibility? Okay. That's a decent amount of people. Very good. I love it. Cool. And can you do that same noise hand thing if you have ever built or designed something with accessibility in mind? Okay, I have my people. That was maybe about 1/6, 1/7 of the audience. And then my last question is, can you do that same thing if you have ever had to build something to be compliant with a legal requirement for accessibility? Yeah, 3 people. Woo! All right. Well, cool. Okay, so those of you who did just raise your hand, hello, welcome. We're going to get through this together. Everybody else, get ready, because the day is coming that you will have to build something to be compliant too. So starting this talk off very well with a lot of fear. All right. So let's all get on that same page, though. Accessibility, what is it? It's the design of products or services or places or stuff for people with disabilities. It's also, oh, come on, clicker. Yeah, there we go. Accessibility is also about removing barriers that would prevent somebody with a disability from being able to use something fully. And really, accessibility is about inclusion, making sure that those of us with disabilities are fully able to participate in society the same as everybody else. Unfortunately, in the digital world we work in, accessibility is rarely a priority in projects. I have a lot of anecdotal evidence to back that one up, but I also have numbers. Ooh. WebAIM, which is a major accessibility or digital accessibility group, about a year ago now, did this really cool scraping of the 1 million most popular websites by traffic volume, looking just at their homepages, just with automated accessibility testing. 97.8% of those 1 million most popular websites had a significant accessibility failure just on their homepage. Pause for effect. That's a lot. Those of us who have accessible homepages are like a rounding error. It's like we don't even exist. Okay, this is a huge, huge problem. And when accessibility is a priority in a project, it's usually from a compliance perspective. It's rarely seen as anything else. So let's take a step back, and let me get you all on board with what the laws are around accessibility, because this talk is about moving beyond those laws, so let's know a little bit about them. 2 notes. 1, I don't have all day, so this talk is going to be scoped to legal compliance in the United States. Laws vary a lot around the world, and if you want to talk to me afterwards, I can tell you all about compliance laws where you do your work. But the concept of compliance and laws is pretty much the same around the world. Second note, I'm not a lawyer. I'm not your lawyer. This isn't legal advice. Please do not sue me or my employer. Thank you. Yay, okay. Now that we got that out of the way. 2 laws in the US you mainly need to know about. First one I'll go over pretty quick. It's called the Rehabilitation Act. It was passed in 1973, and it's a labor law. It prohibits discrimination on the basis of disability in essentially federal programs, if you receive federal funding, if you're a federal employee. The word federal is in there a lot. And Section 508 is what you may have heard of. That's specifically the part of this law that says that information technology must be accessible. So if you're doing anything that receives federal funding or you are a government entity, you need to comply with this law. However, the one that's relevant to pretty much the rest of us is the Americans with Disabilities Act, or the ADA. This was passed in 1990, and it is a civil rights law. It prohibits discrimination on the basis of disability, and it affords similar protections against discrimination as the Civil Rights Act of 1964, which made discrimination on the basis of race, religion, sex, and national origin illegal. And as we all know, if a law says you can't discriminate, then nobody does it, right? The other thing I want to point out here that a lot of folks are surprised by is that Civil Rights Act was passed in 1964, but those of us with disabilities didn't have legally protected civil rights until the 90s, so that's cool. The other thing to know about the ADA is that compliance is enforced via lawsuits. There's no government entity you can call up and go, hey, this website isn't accessible, or this building I want to go into doesn't have a ramp. Instead, entities are sued. And I could go into a lot more detail about this, but for a fun time, look up what other businesses in your industry have recently been sued for a digital accessibility lawsuit. There's a lot. Okay, so now that we're sufficiently terrified of laws and compliance, let's think about how do we know if we meet legal requirements. It's relatively straightforward. We have something called the Web Content Accessibility Guidelines, or the WCAG, or the WCAG, because this acronym is awful to pronounce. It's a set of guidelines that specifically talks about the web, but is very useful across any sort of digital application with a user interface. There's a ton of guidelines inside of it, but 4 main principles. The things that we make in order to be accessible must be perceivable to the senses, operable through a wide variety of different means, understandable to a variety of users, and robust. That is, it must work with a bunch of different kinds of technology. So we have these guidelines. We can follow them. They're written in a pretty technical way, but relatively clearly once you're used to them. So what's the problem? We've got these guidelines, we've got laws. Ta-da, we should be fine, right? Talk over. No. The WCAG is what's considered sufficient for accessibility. It's not what's ideal for accessibility. Compliance with those laws, like the ADA and the Rehabilitation Act, and a wide variety of other laws around the world, is just a passing grade when it comes to accessibility. This would be like if you turned in your homework and you got a D on it. Yeah! Woo! I know my parents are happy with that one. No, not at all, right? A D means you didn't fail, but that's not a very good grade. When we use the WCAG as our testing criteria, and when we think about laws as our testing basis, we're committing to getting a D on our homework when it comes to accessibility. We're saying we're just going to do the bare minimum. And a lot of places, especially consulting firms, will often, use this as a selling point, right? And say, oh, well, we can make websites that are WCAG 2.1 AA compliant, which is the same thing as saying we can get a D on our homework. We're awesome. Yeah. It's not very good. The other reason this is bad is that compliance isn't future-proof. If you're building to just comply with current laws, you're not thinking about how laws and case law may change in the future. The WCAG itself was just updated a little over a year ago now to finally include a bunch of guidelines about mobile accessibility. And suddenly, everybody who was only thinking from a compliance perspective had a website that was out of compliance because they weren't thinking ahead. The other thing I like to think about is that aiming for legal compliance with accessibility doesn't feel good. When you launch a website and all you're thinking about is legal compliance, like, hooray, we're not going to get sued. Gosh, high fives, yeah. Barely acceptable, we did it, yeah. No, it feels like crap to only care about things out of this fear perspective. So, I propose, what if we have a different way we can think about accessibility that isn't just a passing grade? And to really explain this, I want to go over why we have the Americans with Disabilities Act. Told you a little bit about it already, but history time. Can I get a half-hearted woo? That was not half-hearted enough. That was way too excited. Okay, fine. So, history time. Okay, cool. I have a series of images. These are all of different protests that I will be describing. And this is some text from an article called Capitol Crawl. On Monday, March 12th, 1990, disability rights activists descended on the U.S. Capitol demanding the passage of the ADA. The ADA was passed by the Senate the year before, but was finding complications getting through the House of Representatives. Over 1,000 protesters came from 30 states to protest the act's delay. After the day's rally and speeches, over 60 activists abandoned their wheelchairs and mobility devices and began crawling up the 83 stone steps to the U.S. Capitol building, during which people were loudly chanting, "What do we want? ADA. When do we want it? Now." Other activists remained at the bottom, holding signs and giving encouragement to the crawlers. Quote, "I want my civil rights," Paulette Patterson of Chicago stated as she was inching her way to the top. "I want to be treated like a human being." This is from The History of the Americans with Disabilities Act by Arlene Mayerson. The history of the ADA did not begin on July 26, 1990, at the signing ceremony at the White House. It didn't begin in 1988, when the first ADA was introduced in Congress. The ADA story began a long time ago in cities and towns throughout the U.S., when people with disabilities began to challenge societal barriers that excluded them from their communities. The ADA owes its birthright not to any one person or any few, but to the many thousands of people who make up the disability rights movement. People who have worked for years organizing and attending protests, drafting legislation, speaking, testifying, negotiating, lobbying, filing lawsuits, being arrested, doing whatever they could for a cause they believed in. Without the work of so many, without the work of the disability rights movement, there would be no ADA. Pause for effect. We have the ADA and the WCAG as well as that set of web guidelines because we, those of us with disabilities, have demanded inclusion and because we fought for it, not because some friendly people decided, let's give those people with disabilities some rights today. And the WCAG exists because we want the web to improve our lives and not just get in our way, right? So really, I think that focusing on legal compliance doesn't actually capture the reasons that we care about accessibility. And diminishing accessibility to just legal compliance, just complying with the WCAG, erases the entire history of the disability rights movement. It also erases the work that we're still doing to advocate for ourselves. So, with that in mind, let's move beyond thinking about legal compliance and into valuing inclusion and empathy. Haha, okay. So I asked the question, what would it look like if we used inclusion as a test criteria instead of just complying with a set of very technical guidelines? Well, I argue, and in my professional experience, I have found that the best way to evaluate inclusion is to build our skills in detecting inclusion, which is building empathy. So, how do we build that empathy? How do we know if we've passed this test criteria of inclusion? My first big major recommendation is to learn about why the WCAG guidelines are the way they are. So if you're somebody that's worked with them already, I'd like the folks in the audience who've raised their hands, and if you haven't worked with them yet, get ready. You will be soon. It's the way our industry is going. When you read through the WCAG guidelines, at the very top, after the definition of what the guideline is, you'll see a section labeled intent. And this goes into a wonderful amount of detail about why is this written the way that it is? Who is it meant to help? What are their limitations? What does passing the success criteria actually mean for a real person's life? So you can start to think of those criteria not just as something to comply with, but as something you care about. My next major recommendation for building empathy is to read a book. Wow, or listen to a book or, an audiobook, I don't care, whatever. Here's some book recommendations if you want. I am a big fan of the Disability Rights Movement by Fleischer and Zames. Accessible America, which is a history of disability and design by Bess Williamson. My major recommendation for those of us who work in tech, however, is Accessibility for Everyone by Laura Kalbag. It's in the A Book Apart series, and it is fantastic. It's not too long of a read. It will really give you a solid foundation of accessibility for everyone in the digital things we make. Okay, what else can we do? Well, I recommend you follow disability rights activists and pay attention to what they're saying. If you want, I think I actually have a whole Twitter list of recommended people you might follow on Twitter. Oh, I have my Twitter handle. I forgot to mention it on my slides, Sublime March. If you've been live tweeting my talk, you're my new best friend. Sorry, old best friend. Anyways, good thing my wife's not here. She's my current best friend. No, too bad. Anyways, so follow people on Twitter and pay attention to what they're saying. Really what you want to do is to listen to our experiences and needs. And even those of us who have disabilities, no one has every different kind of disability you could have. So we all need to be doing a better job of listening to one another's experiences around digital accessibility. Okay, this is all well and good. You might be like, okay, Fen, I get it. I care about people. I don't want to just follow the law. I want to do better than that, blah, 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 blah. This is totally useless to me unless you tell me how this actually applies to my job. Don't worry, I got you. So, how do we apply inclusion as a testing criteria with the digital things we make? First off, when you're testing against the WCAG, you might be using some cool automated tools, which I have a bevy of recommendations if you want to chat later. My personal fave is AxeCore and Accessibility Insights made by Microsoft. You might use those to do some automated accessibility testing, as well as some manual testing. There's certain things that just we can't write code to automatically test. A person has to look at it. In addition to that, though, you should be adding to your list of tests to run is a test with an expert, aka an actual person with disabilities, multiple people with disabilities. We're experts in our own experiences and needs. Way better than a line of code you can write is just asking somebody, say somebody with color blindness, hey, do these colors look all right to you? Can you read this? Can you understand this well enough? It's way better, way better. You're going to get way more information. I also recommend that you do user interviews with people with disabilities before you build something. If you have a current user base, talk to them, especially if you have an existing product of some kind. What's working? What's not working? How do you use this thing we've made right now? Oh, that's interesting. Get that data. And then do user testing with people with disabilities throughout the process of creating the thing you're making, and especially at the end. If you're already doing user acceptance testing, it's pretty easy when you're already making sure that you have a cross-section of different kinds of users representing different stories and modalities of interacting with your product. Make sure that some of those people also have a disability of some kind that impacts how they might use it. Keep track of that. It's pretty easy if you're already doing user testing. The thing to keep in mind is that those automated tests we might use to check the accessibility of a product supplement user testing. They're in addition to testing with an actual user, we can get more information from automated tests, because automated tests are quicker, more reliable, you get the idea. It's not the other way around. It's not we have automated tests, and if we're confused, we talk to an actual person. It's a kind of different way of thinking for those of us who are programmers, but automated tests are meant to be sort of a facsimile of testing with an actual person with a disability. I would argue, though, that one of the best ways that you can integrate accessibility testing with a person into your flow is to just hire people with disabilities. It's way easier than having to go externally and recruit testers and things like that. If you have a dev on your team who's colorblind, or someone with autism, or someone who uses a screen reader, it's really easy when that person is making a thing to know if it's working for them or not. Hire people with disabilities, please. In addition, I recommend creating a checklist for accessibility that goes beyond just user testing and evaluating against the WCAG. What would a checklist like that look like? Something like this. Wow, lots of tiny text. I'll go through it. This is essentially, at Click, what we use, in addition to just saying, oh, treat the WCAG guidelines as our testing script, go through them one by one. We have achieved accessibility, or, as good as we can get, if we've done the following things. We've done an accessibility risk assessment on the project. How likely is it that this client of ours might get sued, or things like that? We do a target user review to identify user groups that have a higher accessibility need. Say, for example, I have a client that provides social connections via an app to elderly folks. They are more likely to have higher rates of different kinds of disabilities. So that's an important aspect of evaluating those users. Also, a training for the client or the business of whatever that might be on why accessibility matters early on is another criteria I'm looking for. Also doing user interviews, as we mentioned a minute ago. Reviewing wireframes and designs. Either your design team should be doing that themselves, or somebody external, or if you have a dedicated accessibility person like me, they should be looking at that. Accessibility-specific check-ins with developers, user acceptance testing with people with disabilities, a bunch of automated testing before launch, manual testing by somebody who is trained and a professional. There have actually been a lot of lawsuits recently where the defense that the company that has an alleged inaccessible website, their defense has been, oh, well, we had somebody look at it. We had our random developer who doesn't know anything about accessibility run an automated test. That's the same thing, right? Make sure you're having a professional look at it. Also, part of this checklist is having a training session with either the client or whoever will actually enter content or whoever is going to manage the site once it launches or manage the app or whatever the thing is, giving them a training session on how to keep that project accessible. It doesn't stop being an accessibility problem once it hits the world. And then an accessibility-focused review of their brand guidelines and all the other products or all the other materials that they give us that would go in this app. I'm just tired from listing all of that, but really it's a lot of little things that integrate into an existing process. I also recommend identifying accessibility-related performance metrics. That sounds so businessy. Maybe I should say find ways to evaluate accessibility. I don't know, whatever. Identify accessibility-related performance metrics. What might that be? Here are two real-world examples that I've used with my clients. On one project, a KPI we identified was that we wanted to reduce the number of phone calls that our client would get related to the on-site accessibility. This was they have a physical performance space. And we knew that if the website was sufficiently accessible, people with a disability wouldn't have a need to get frustrated with the site, pick up a phone, and call them to ask a question about the accessibility of their venue. They would be able to find that information without any barriers on the actual site. For another client, we had the goal of if this site is sufficiently accessible, it's a university, they wanted to increase the number of students with disabilities applying to their program. Because one, we're not presenting barriers to those potential students accessing the application form, but also if the site is accessible, we are showing to these prospective students that this university cares about them, thus making them more likely to want to apply. Other things we've done are if the site is sufficiently accessible, we won't have to have as many physical maps in the venue of this space, this museum. Interesting things like that. How can we use accessibility as a metric? I also recommend identifying user stories that involve accessibility. So you might already have a user story of, oh, as an administrator, I want to be able to X so that I can Y, whatever the user story might be. Add in user stories that involve people with disabilities. So as a screen reader user, I want to be able to X, Y, Z. Or as an administrator who uses a screen reader, whatever that might be. In the same way that you would evaluate against those user stories to determine if you've succeeded in creating the thing you're trying to create a user story related to accessibility. And lastly, train developers to see beyond just the WCAG. Make it so that way they want to make the thing they're making an even better experience for people with disabilities, ideally by helping build empathy. So really, in conclusion, to help people with disabilities, you have to aim for more than just a passing grade. Especially, or even if your client or the business, if all they care about is legal compliance, you can still define what accessibility looks like as more than just legal compliance. Because like I said before, legal requirements are always changing, and new precedent is being established constantly. So you can stay ahead of those changing legal requirements by using empathy. It's almost like you suddenly have a superpower to predict the way that laws might go just by caring about the people that those laws are designed to protect. If you pay attention to one thing from this whole talk, it should be that you need to listen to people with disabilities and not just think about legal compliance. Thank you.
Thank you, Fen. Okay, we have coffee break now, and at 4:35 we'll get back to Brandon Warren, Introduction to the Quantum Bit.
Hey, also, just as a reminder, there is food downstairs where the reception was last night, and also where there was breakfast food out this morning. There is still quite a bit of food out, so please go and eat and subsidize your dinner a little bit. Yeah. We'll see you back. 4:35 or 4:30.
the land and chills the breeze, touches with her hand the summer tree.
Hello, welcome back from break. Our next speaker is Brandon Warren, who's here to introduce us to the quantum bit. Welcome, Brandon.
Thank you. Thank you, everybody. I'm Brandon Warren, and I work at Zonar, but my talk has absolutely nothing to do with my day job. Quantum computing takes advantage of two of the most mysterious concepts of quantum physics, superposition and entanglement. Today, I'll focus on the basic building block of a quantum computer, the quantum bit, or qubit. We'll be using QISKit, IBM's Python-based open source framework for quantum computing, and we'll run an experiment on a real quantum computer to see if Einstein was correct in his most cited paper. This whole presentation is on GitHub, so if you miss a slide or you want to run this code on your own, you're all set. A classical bit, the kind we all know and love, can contain a 0 or a 1. A quantum bit can contain a 0 and a 1 at the same time. That's the superposition part. It can also have exotic relationships with other qubits, relationships that transcend time and space. That's the entanglement part. A qubit can be a photon, electron, or anything else small enough and or cold enough to exhibit quantum properties. IBM's qubits are large, about 0.1 millimeter across, but they're super cold, about 0.02 degrees above absolute zero, which is 100 times colder than interstellar space, which is 2.7 degrees Kelvin. So let's get started. Here's an actual IBM quantum computer. Starting at the right, we see a chip with 6 superconducting qubits. To the left of that, we see the printed circuit board that contains that qubit chip. And to the left of that, the refrigerator that cools the qubits down to 0.02 degrees Kelvin. And then to the left of that, we see the microwave electronics that interface our classical computers to this quantum computer. So here's some code we'll be using, just importing the QISKit functions and another function to set the backend, which we will now use to set the simulator to run our quantum circuits, saving our real quantum computer for the last. Next, we want to write code that will build this super simple quantum circuit. Logic flows from the left to right, and the quantum bits always begin in a ground state, which always measures 0. So starting at the left, we see Q0 and Q1. They're in a ground state, and then immediately after, they're measured with these 2 measurement devices with the results placed on the classical register. Here's a Python code to build that circuit. We create a quantum register that contains 2 qubits, a classical register containing 2 classical bits, and from that we create a quantum circuit and then add measurement devices, and then we'll draw it. Looks the same as what we hoped. So let's run it 1,000 times on the simulator. We have 2 qubits, and 2 possibilities. So we have 4 possibilities, but of course they're always 0, 0, because they start off as ground in the ground state, which is always 0. Let's add another gate. The X gate is a NOT gate. We'll apply the NOT gate to the high order qubit, run it 1,000 times, and we see, no big surprise, the high bit is 1, the low bit is 0. So we've seen the 2 simplest quantum circuits possible. Let's take it up a notch and place each qubit into a quantum superposition. What the hell is that, you're probably wondering. Oh, I got a couple definitions. I'll just talk about the simpler one. A quantum entity exists in a superposition when it's in 2 or more states or positions at once. once observed, it becomes one of the states and acts like it was in that state all along. Kind of like if you flip a coin, we can imagine while it's spinning, it's heads and tails, kind of. But when you catch it, it's heads or tails. And one funny difference is, once you measure it and you find out it's heads or tails, it acts like it was that state all along. What's the difference between that and having a coin under a piece of paper that's suddenly revealed? The double slit experiment will tell us. It has in it the heart of quantum mechanics, and in reality contains the only mystery, says Richard Feynman. So let's look at the double slit experiment. First, let's review what happens when we add waveforms. If we have two waveforms and they're perfectly in sync, that is, they have 0 degrees phase difference, then the positive peak of one lines up with the positive peak of the other, and when they're added, they create the same waveform, that twice the amplitude. At the other extreme, if they're exactly 180 degrees out of phase, the negative peak of one will line up with the positive peak of the other, and when they're combined, we get 0. If it's light, it would be a darkness. Here's the double slit experiment. To the left, we have a light source. This diagram shows electrons, but electrons show the same behavior. So I'll just talk about light. The light goes and hits this barrier, which has two vertical slits, and then these two waveforms come out of that and combine on the screen. When the light from the two slits combine on the screen, we see this pattern on the lower panel that shows us the vertical dark bands, and that's where the interference, that is where the out of phase light waves are interfering with each other, creating darkness, as opposed to the upper panel, which shows us what it looks like with a single slit. But what happens if we turn the light source down so low that only a single photon, because light's also a particle, goes through the apparatus at a time? We'll see the same pattern build up over time. And so it's as if each individual photon is going through both slits at the same time and then recombining with itself right in front of the photographic plate. So that's a superposition, being in two places or two positions or having two states at the same time. Like a photon that's in two places at once, a qubit can be in two states at once and become 0 or 1 when it's measured. Let's place our two qubits in a superposition and measure them. The act of measurement collapses the superposition, resulting in one of the two possible states. We'll use the H gate, which is a Hadamard gate, and that will turn our 0 into superposition of 0 and 1. And the way it works is it kind of rotates the state of the qubit 90 degrees. And we can kind of think of it with an analogy. Let's say we have a coin over this table, and it's parallel to the table, heads up. If you drop the coin, it'll land heads up. But if we take the coin and rotate it 90 degrees, when it lands, it'll be edge down, and then we have a 50% chance it'll be heads. That's kind of how the Hadamard gate works. So we add the Hadamard gate to both qubits and then take measurements right afterwards. We'll run that, and because each qubit can be a 0 or a 1 when measured, we have all four combinations with equal probability. Let's talk about a very special case of the superposition, entanglement, which was revealed by the EPR experiment, which we will now talk about. The EPR experiment is as close to magic as any physical phenomenon I know of, and magic should be enjoyed, said David Merman. Before we get to that, I'd like to set the stage by introducing two concepts, locality and hidden variables. The principle of locality says that for one thing to affect another, they have to be in the same location or need some kind of a field or signal connecting the two, with the fastest possible propagation speed being that of light. This even applies to gravity, which propagates at the speed of light. For example, we're 8 light minutes from the sun. What if the sun disappeared somehow? All of a sudden, we wouldn't know it. We would still orbit around the sun for another 8 minutes before flying off into space. Even though Einstein helped launch the new field of quantum mechanics, he never really liked it. In particular, he couldn't accept the randomness. He was convinced that God does not throw dice. To which quantum theory, Niels Bohr, stopped telling God what to do with his dice. Einstein felt strongly that the results from particle interactions were deterministic. Like, let's say we flip a coin. If we know if it's heads up or heads or tails up on our thumb, and then we flip it, and we know the upward velocity and the spin rate, air density, all the parameters, including the distance from my hand to this table, we'd be able to predict whether it's heads or tails if we knew all the measurements. So it really is deterministic. It's only our ignorance of the variables that make it appear random. Einstein called the variables we're unaware of hidden variables. He also believed in realism, that a particle will have a definite state before we look at it. But quantum theory insisted that measured results really are random, and that until they're measured, they have no reality. Einstein called BS on that. In 1935, Einstein, along with two co-authors, Podolsky and Rosen, published what became Einstein's most cited work, now known as the EPR paper, after the three authors. They proposed an experiment where two particles interact in such a way that if you made the same measurement at on the same axis on both particles, the results would be opposite, like +1 or -1, or heads and tails. After the interaction, the particles travel far apart until they are independent from each other, so that measuring one cannot affect the other. Notice they're assuming the principle of locality. Let's say we measured one and it's heads. Then we know the other one has to be tails. They're too far apart to have interacted, so the other one was already tails. Therefore, it's not random. There must be hidden variables to explain responsible for the values. Therefore, quantum theory is incomplete. That was their argument, and it was compelling. Later that same year, Schrödinger replied with a seminal paper defining the new property he named entanglement. So now we have two camps formed: Einstein versus quantum theory. Einstein camp believed that locality, the principle of locality, should apply to particle physics, whereas the quantum theory camp believes in this new property they call entanglement, which Einstein derides as spooky action at a distance. Einstein camp believes in realism. Einstein stated the moon is there even if I'm not looking at it, whereas quantum theory camp insists that reality doesn't exist until it's measured. Einstein believes in a deterministic universe. Quantum theory says random things do happen. Einstein's camp seems to make sense to me. The other one's out there. So I'll just kind of describe entanglement again with coins. So I'm flipping two coins. Somehow I magically entangle them, but it's a real physical process with particles. And then we separate them a great distance. While they're still spinning, I catch one, and if I see that it's heads, the other one stops spinning and becomes tails. And that's an odd parity entanglement. You could also do a different kind of physical interaction that results in an even parity entanglement, where if this is heads, then the other is heads. Let's create a quantum circuit that will create an even parity entanglement. So we have the Hadamard gate on bit 0, putting it into a superposition. Then after that, this plus is a controlled NOT gate, which it will flip its input, which is Q1, if that target is true. And so if that target's a 1, it will flip the input, which is 0, into a 1. If the target's a 0, it will leave the input alone, which will be 0. Therefore, the two lines that are being measured will always be in the same state, but they're also in a superposition, so that's kind of weird. Let's run it 1,000 times, and every time it's either they're both 0 or they're both 1. And we can make a slight modification to that circuit to make it an even or an odd parity entanglement by adding a NOT gate to one of the bits. If we run that, now every time we run it, it's either heads tails or tails heads. So we just ran the EPR experiment and got highly correlated results as predicted. But think about it. How can you get high correlation between two random observables? If they're random, the correlation between the two should be close to zero, not almost perfect. The only explanations I can think of, one, they're not really random. They're hidden variables that we're not aware of, making them appear to be random. That's Einstein's position. The other is that there's some weird link between the two, so that if you observe one and it collapses a superposition, the other one instantly collapses a superposition. So that's a situation in 1935, and there's no way to tell who's right. This argument went unsettled for 3 decades, until 1964, when John Bell had the insight to tweak the experiment by considering the results if the measurement axis was rotated by some angle. Depending on the angle, the correlations would no longer be perfect, and the predictions of quantum theory would be different than those of EPR. So at last, we have a way of finding out who's right. So here's the kind of a summary of the Bell experiment, which is a modification of the EPR experiment. We still have two particles, A and B. They still become entangled and move away from each other. But for each particle, we now perform one of two measurements. Particle A, we measure at two different angles, 0 degrees and 90 degrees. 0 degrees is how we've been measuring so far. Measurement on particle B, they're either 45 or minus 45. And so we do all 4 combinations and calculate the correlations between those. And note that for each experiment, the difference is 45. So like the first one, 0 and 45, that's 45. 90 and 45, it's 45. The only exception being the last one, A prime versus B prime, is 90 plus 45. But that's the same as 180 minus 45. So now 180 would be a negative correlation, but still with a 45-degree offset. And that's why we negate that last correlation you see on the right. Right here. And so we run all 4 experiments 1,000 times, plug the correlations into C, into the formula for C, and if C is less than or equal to 2, Einstein is right, the inequality is satisfied. And this is the outcome that Bell expected. He thought Einstein was right. So let's run the Bell experiment on a real device. And I would be about to do that. Unfortunately, over the past few days, the wait times for the real quantum computers have gone from a couple of minutes to over an hour. So I'm going to be like in the cooking shows where I just prepared everything, put the cake in the oven, and now 1 minute later, I'll pull the cake out of the oven and show what happened. So here I set the back end. It's using one. And then I set up the code to create the entanglement and then set up the circuits to do our 4 different measurements. And we can see, like this measurement is the Q0 is measured at 0 degrees. That is, we just have this measurement right away. And then the other one, we have those 4 gates which have the effect of rotating the qubit 45 degrees. And the same thing here. It's the same thing as above, except these 4 gates rotate at negative 45 degrees. And then this, just like the first, except we have that Hadamard gate to rotate Q0 90 degrees. So then, with that all defined, we then execute it. We gather the data. And note when this was run 2 days ago, it took 100 minutes for the job to get picked up. And I didn't think you wanted to wait that long. Oh, here's a little bonus. Remember before I showed you the histogram of an even parity entanglement, and it was perfect. It was always 0, 0 or 1, 1. But on a real device, because real devices still have noise problems, we still get some data on the 0, 1 and 1, 0. And that's why quantum computing isn't breaking encryption yet, is because noise is preventing quantum supremacy. Here's where we calculate the output. And now we'll find out what the value of C is. It's 2.4, greater than 2. Einstein is wrong, quantum theory is right. And local hidden variable theories cannot explain the results. And entanglement is a real non-local property that transcends time and space. And to conclude, I'll just review a few things. Superposition is demonstrated by the double slit experiment, which suggests that a photon can be in two positions at once, because the interference pattern only forms if two photons interfere with each other, and it forms even if we send one photon at a time. Hidden variable theories seek to provide determinism to quantum physics. The principle of locality states that an influence of one particle cannot propagate faster than the speed of light, and entanglement cannot be explained by local hidden variable theories. And two of the strangest concepts in quantum physics, superposition and entanglement, are used in quantum computing and are waiting to be explored by you. You can run simple experiments on your laptop, and when you're ready, run them on a real quantum computer over the cloud for free. IBM's QIS kit contains software, tutorials, and an active Slack community. And my GitHub repo contains this whole presentation and tips on how to install a QIS kit and more links for more detailed information. If you have any questions, please come see me afterwards. I love talking about this. Thank you.
Thank you very much, Brandon. I learned something. So everyone, it's time now for another break. Please join us again at 5:10, where we get to learn about code reviews from Mina Slater. In the meantime, just keep in mind that after today's presentations, we are planning to do the group photo. So if you are interested in being part of the group photo, please make sure to stick around after the next presentation. Thank you. See you back at 5:10.
Most of these things have very little to do with syntax, which was what the program I went through focused on teaching us. About 2 months after finishing my apprenticeship and becoming a billable member of the engineering team, I joined the largest project at my company. Of the 14 developers that we had overall, 6 were on this project. That's really big for my company. So with a team of this size, it is especially crucial to have a structured feedback loop for our work. So fun fact, this is the first and only lines of Python code I have ever written, so don't judge. Anyway, during my onboarding to the project team, I was introduced to this process. First, a pair of engineers write some code. They open a GitHub pull request when they're done to propose merging their code into the main code base. The other engineers on the team review this request and either approve it or request changes. Rinse and repeat that process until about 50% of the team give their approval, and we merge. Now, I was not only expected to put up my code to be picked apart, I was expected to comment on someone else's code. I had very little experience at that point reading code I didn't write, let alone commenting on the quality of it. What was I supposed to be looking for? Am I even qualified to be doing that? What if I asked stupid questions? I understood that we use this review process as a way to keep our code styles and patterns consistent and share knowledge about different parts of the project across the team. With 3 pairs of engineers on the team, it's unlikely that we would personally touch every part of this code base. In theory, I was on board. In practice, though, I was terrified. Now, luckily, I had a super supportive team that helped guide me through this learning curve. And after some trial and error, I came to the learnings that I'm going to share with you today. Now, there are many different types of code reviews. For instance, we sometimes refer to the interview session during which an applicant's submitted code samples are discussed, also as code reviews. But for the purpose of this presentation, the term refers to the reviewing of a pull request on a team with many contributors. So in our workflow, it's this point, where someone who was not involved in writing the code originally checks it over to verify that the feature or bug fix is indeed ready to be incorporated into the main code base and possibly deployed. Now, there are 2 different roles that we could play in the event of a code review. You could either be the reviewee, the person whose code is being reviewed, or the reviewer, the person reviewing said code. Now, since the main purpose of this presentation is to bridge the knowledge gap between coding bootcamp and the real world, we're going to get started as the initial writer of the code up for review. Now, this is likely the point of entry for early career engineers and most definitely where I got my first experience with code reviews. Okay, so when I first began opening pull requests on a project with other team members, I quite literally didn't know what I was doing. I didn't know where to start. Okay, so I've written some code to complete a task I was working on. Now what? Luckily, our project uses a PR template to give me somewhere to start. It looks something like this. Now, since we pair, the template reminds us to include both our own name as well as the name of our pair. It has predefined sections for listing changes. And since our project's front and back end are separate repos, the template also reminds us to link any dependent PRs. Now, this was really helpful in getting me to start thinking about what to communicate to my teammates about the code changes in plain English.
So now, when I fill out this template, I consider the following questions. What the actual changes are. Did I add new classes or make modifications to the existing code, and what those modifications are? Why did I make those changes? What were the motivations behind them? What should my reviewers be paying extra attention to? I typically point out any implementation details that I was flexible on or unsure of, and link those dependent PRs. And I include any GIFs, videos, screenshots of changes in the UI, because a picture really is worth 1,000 words. So, for example, my pull request description might look something like this. As you can see here, I have pointed out the changes I made in the code and a little bit of reasoning behind them. I have included something that I want my teammates to pay attention to. So we need to make sure that we merge in related front-end and back-end PRs at the same time, so I've linked them. I have also then attached a screenshot of the new, what the new UI looks like. So I like to put as much detail in the PRs in the PR descriptions as I can. So for this reason, I will also recommend keeping our PRs small. Group-related changes into their own pull requests. 3 PRs of 300-line changes are more manageable than 1 PR of almost 1,000 lines. Okay, so we've opened our pull request, and our teammates have left some comments and thoughts. What do we do now? Well, with written communication, there is always a hint of implicit negative bias when we're reading it. We have a tendency to attribute a more critical or negative intent in feedback that is delivered in writing as opposed to verbally, because tone is a huge part of language and human understanding. So when receiving any kind of asynchronous feedback, this negativity bias is something that I try to keep in mind. I usually try to read the suggestions left on my code with as neutral a tone as possible. Still, I often catch myself prescribing intent to my reviewers' words and have to sort of work to correct my perspective. Because at the end of the day, we are not our code. As the engineer on my team with the least experience, my PRs will often receive more suggestions for improvement or requests for change. Without detaching myself from my code, these reviews would be such a different experience. Now, coding is not an easy task. Usually by the time that we're ready for the code to be reviewed, we had just spent hours, possibly days, toiling over implementation details, hunting down bugs, and identifying all possible edge cases for testing. Metaphoric, maybe literal, blood, sweat, and tears got us to this point in the process. But now we have to expose our code baby up for scrutiny. It's hard not to feel protective or even defensive about it. But I try to remember that it's nothing precious. First off, our reviewer suggestions are how we make our code better and ensure that we're shipping quality work. Also, getting constructive feedback on a pull request doesn't mean we're bad engineers. In fact, I suggest looking at these as opportunities to grow. A PR with instant approval doesn't provide us with anything to learn from it. Now, a lot of us recently out of boot camp and newly on the job sometimes have dealt in anxiety about our knowledge and skills. Imposter syndrome truly is real. So for the good part of this last year on the project, I made every change that my teammates suggested on my pull requests without question. I assumed that because they were more experienced, they knew better. Now, in a lot of cases, that was true, but not always. I tried to be an active participant by asking questions if a comment or suggestion from a reviewer isn't clear to me. Code reviews should be open team discussions and opportunities to collaborate and learn from each other. So even as someone new to the industry, bring up counterpoints to suggestions if our understanding differs from that of the reviewer. We don't have to implement every change request blindly. Ask for clarification or offer alternatives. Because even if we do eventually make that suggested change, the discussion usually results in a lot of learning. They can help us understand the motivation behind the change and provide us with something to consider the next time we are faced with a similar task. And now that we know a little bit about how to have our code reviewed by others, let's take a look at the same process from the other perspective. So, in addition to having my code reviewed by the rest of the team, I discovered that I was expected to return that favor. Critiquing the code written by someone more experienced than me was a daunting task to face. I knew I shouldn't, but I was inclined to just approve everything my teammates put in front of me. I realized that it was doing my team a disservice and really borderline not doing my job. But I was so afraid of exposing my perceived ignorance and not sure whether pull requests were the right place to ask for explanations about things I didn't understand. Now, I came up with some actionable steps to follow every time I was reviewing code. This structure gave me something to ground my approach, and the routine actually absorbed some of the anxiety. So first of all, like putting extra care into writing my PR descriptions, I make sure to read the descriptions written by other people, as well as the commit messages and the previous conversations already going on in the PR. This gives me context about the purpose of the PR before I dive into the code. It usually helps me understand what to pay attention to, and it sets a solid foundation for my reviews. In my experience, the easiest way to start an intelligent code review is to arm myself with all the information I can. That way, I will be able to ask thoughtful questions and give informed suggestions. Next, I pull the feature branch from GitHub, and I run that code locally. Doing this lets me test it through the UI, and if there is one, as well as running all the tests. I also find it easier to navigate through the code base when it's open in my text editor rather than online in GitHub. Now, the website really only shows me the lines where the code had been changed, so I find it challenging if I needed to look at other parts of the code base not related to the PR. Now, once we have looked through the code changes and are ready to give feedback, we want to be as clear as possible when asking for change. I often include resources like links to documentation and blog posts that reinforce or demonstrate the suggestion. This will give them some context into my reasoning for the change request. Now, my suggestions might bring up something that the reviewee didn't consider and help avoid a potential bug in the future. Always remember, though, to do it with empathy and put ourselves in the shoes of the reviewee. It's hard sometimes, like we've discussed, to separate ourselves from our code, so be sure to provide critique in an empathetic way. It sets up the review as constructive and non-judgmental. The ask model of providing feedback is the structure I like to adhere to. So we have A for actionable, S for specific, and K for kind. Now, I was told once something that I find very interesting, that constructive feedback is still kind feedback, and nice feedback is not necessarily kind. So let's look at some examples. So this example says data model could improve. Now, to me, this is not a valuable feedback because it's not actionable nor is it specific. So what parts of the data model could improve? And how could it improve? And what would that improvement add to the quality of the code? The reviewee here could potentially make a guess and update something about the data model, but it might not be what the reviewer meant. and thus adding another round of back and forth on the PR. So this next example says, looks good. That's it. This comment is nice at first glance, but not necessarily kind at all. This was the type of feedback I was giving my teammates when I first started giving reviews. I didn't feel qualified to voice my opinion, and they've been coding for so much longer, they must be right. Now, it wasn't until I started asking questions and got responses like, oh, that's a good point, or I hadn't thought of that, that I realized I have some value to add to this process. So this next example is one that I would consider an excellent PR comment. Just here in the first paragraph, it demonstrates that it's actionable because the reviewer has given an alternative. It's specific because he goes into the reasoning behind the suggestion, and I believe it's kind because he uses the pronoun we, indicating that the responsibility for the code quality is a team effort. It removes blame from individuals. Special shout out to that code example at the bottom. So we want to also make sure to suggest rather than demand. The best way that I have found for this is to ask questions, like this commenter did, rather than using commanding language or absolute statements. Try to start your sentences with, have you considered, instead of you should. Lastly, I almost always leave at least one praise on the pull request. Now, pointing out something that is done well in the code. I have found that this tends to reinforce learning and builds confidence, no matter the other person's experience level. Generally, people respond well to positive reinforcements. Starting a code review through the lens of empathy and with these extra considerations can also slow us down and give us time to check any privilege or power dynamics that we might not have otherwise considered. Now, one of the other engineers on my project team does something that I find amazing, and I have since incorporated into my own reviews. He often offers to pair with the reviewee if he's making change requests that could potentially be complex or time-consuming to implement. Pair programming in general is a time of so much learning in my experience, and pairing to implement code reviews also adds the benefit of shortening the feedback loop and increasing the efficiency of a team. It cuts out some of the suggest a change, make the change, and re-review cycle. If a piece of feedback is complex, verbal communication can be much more clear than the written back and forth on the PR. Now, I was always under the naive impression that engineers write code and someone else, a manager or maybe a lead, will review that code and have the final say about what is ready. Now, I'm sure lots of teams do things this way, but being on a team with a flatter code review structure, where everyone shares that responsibility, I am convinced that this is a more effective way for us. There is a lot that can be learned from reviewing other people's code. It gives the newer members of our team the opportunity to grow. Also, the fresh perspective of a newer developer could surface simpler solutions that more experienced engineers sometimes overlook. It also lets everyone on the team have a voice and take ownership of the project. By giving team members equal footing in the review process, it communicates that everyone's opinions matter, and the more people reviewing code also means that more people understand the code. Code reviews, like anything else, requires practice. The more we do it, the better we're going to become. It was stressful and terrifying when I first joined the team, but after a year on this project, it has become second nature. I am empowered to raise questions on other people's pull requests, and I'm always thankful when they leave comments and suggestions on mine. Now, participating in this process has helped me grow as an engineer. Reading and thinking about code is an effective avenue for learning, and code reviews are exactly that. When performed with empathy and thoughtfulness, code reviews help make sure that we ship quality work as a team. And here are some takeaways that I hope you will think about the next time that you have your code reviewed, or the next time that you're reviewing someone else's code. So as a reviewee, harness code reviews as opportunities to grow and learn. And as a reviewer, approach code reviews as opportunities to collaborate. Thank you.
Thank you very much, Mina. That was great. Again, as a reminder to all of you, that was our last speech of the day. And if you are willing to be in the group photo, please stick around. Otherwise, enjoy your evening. I will turn it over to our photographer in a moment, and who will give us further directions. Thea.
Yeah, right? Hi, friends. All of you who are up on the balcony, you are in the wrong place. I need you down here. So please come downstairs. And everybody who is downstairs, please pull forward and kind of gather in what I would like to call a group so that I can take a photo